If you look at problem number 7, again, just like we did in the previous one, you have to make sure you get a 0 on one side, so I'm going to subtract 3 over x plus 1 on both sides. So I'll do my 0. Again, you have to condense this down to a single fraction, so you're going to have to get a common denominator and then subtract the two fractions. My least common denominator is x minus 3 times x plus 1, so I can multiply my first fraction by x plus 1 over x plus 1. Multiply my second fraction by an x minus 3 in the numerator, x minus 3 in the denominator, to get that least common denominator. Make sure you distribute the 5 to x plus 1, that'll give me 5x plus 5. Now be careful, you're not distributing a positive 3, you're distributing a negative 3. That'll give you minus 3x plus 9. All over your least common denominator of x plus 1 times x minus 3. And again, this is greater than 0. So now I simplify the numerator, 5x minus 3x is a 2x, 5 plus 9 is a positive 14, over x plus 1 times x minus 3 greater than 0. The only factoring I can do in the numerator is I can factor out of 2. Now I should be able to identify my critical numbers. Again, if I set the numerator equal to 0, the critical number is going to be negative 7. If I set the denominator equal to 0, that's going to give me a negative 1 and a positive 3 as my critical number. So I can plot these values on the real number line. So I have negative 7, negative 1, and 3. Again, all the values have to be greater than 0. None of my critical numbers are included in my solution set. So again, if I choose my test numbers, negative 8, again, I'm still plugging it back into the factored form to check. So if I plug in negative 8 plus 7 gives me a negative number in the numerator. Negative 8 plus 1, negative again, and negative times a negative is a positive. So numbers less than negative 7 will be negative numbers. Pick a number between negative 1 and negative 7, I'll choose negative 2. Negative 2 plus 7 is positive, so I have a positive number in the numerator. Negative 2 plus 1 is negative, negative 2 minus 3 is negative, and a negative times a negative is a positive. So positive numbers will be between negative 7 and negative 1. Picking a number between negative 1 and 3, I'll choose 0. 0 plus 7 is positive, so it's positive in the numerator. 0 plus 1 is positive, 0 minus 3 is negative, so I have a negative number in the denominator. That makes numbers between negative 1 and 3 negative. And then if I choose 4. 4 plus 7 is positive. 4 plus 1 is positive, 4 minus 3 is positive. A positive or a positive is a positive number. Again, I'm looking for numbers greater than 0. So I am looking between negative 7 and negative 1, and I'm looking from 3 to infinity. So my solution set will be negative 7, negative 1, and then 3 to infinity.